Hi everybody. Today we're going to do notes a little bit differently, a little bit more self-guided. Make sure you have this paper so that you can write this down. Also, be sure to answer the questions when they appear on the screen. So we're going to start with going back over a parent function that we learned but never really did much with. Now we're going to do everything we can with it, and that is the rational function, or the reciprocal function, 1 over x. Now you know a lot about this already. First of all, we don't really plot points. You should have two asymptotes, one at y equals 0 and one at x equals 0, or x-axis and y-axis. As we move forward, we're going to call those asymptotes x equals a number and y equals a number, so it's a little bit easier if we start that way. I'm going to first of all graph the parent function, which is at 1, 1. It's also at 2, 1/2 and 1/2, 2. So this is what the parent function looks like exactly. That's how close it is to the origin. So it would be -1, -1, -2, -1/2, -1/2, -2. Now that'll probably be the only time we really plot any points. As you know, you just draw the asymptotes and you draw in the branches to fit into the asymptotes. Now, I'm also going to draw this next one, this h of x, just to show you the difference. The asymptotes are still the same. They're still at 0 and 0, or the x and the y-axis. But when we put a 5 in the numerator, it changes this this main point, or it does the turning, to 2, 2.5. And then it also changes to 5, 1 and 1, 5. And so what happens is it moves out away from the origin a little bit. I'm going to put it on the other side as well. I am going to plot these points. So it's -2, 2.5, -5, -1, -1, -5. Now the asymptotes, since they're the same, what will happen as they get further and further away, you can maybe see down here, they will start to merge and become one line. So even though it's two different graphs, the asymptotes are the same, so they actually eventually will overlap. So based on these two graphs, what do you think the numerator controls? The numerator controls the vertical stretch. This is very similar to when we would have a number out in front of the parentheses. The number is not touching the letter x. Just so you know, we will not have a vertical shrink. So we're not even going to have to worry about that. That's not going to be a thing for us. So let's take a look at some other things that these graphs can do. Now I'm going to draw the graphs for you. You can put them in the calculator if that's faster. But we've got the parent function again, which I'll graph that in red again. So our parent function is right here, 0 and 0. And again, we're not going to plot points anymore. We're just going to draw it in. We know it's upper right and lower left. Then when you put in this in the calculator, be careful. This is going to be 1 and then divided by x minus 3. Now, if you can get your calculator to physically have a fraction where you can see the numerator and denominator, then do that. If your calculator, when you go to y sub 1 and it just shows up like this, the division, you have to put this in parentheses. It will draw the wrong graph, and you will just trust your calculator probably and draw the wrong graph. So we want to be careful with that. So when we put this in there, you'll see what happens is this asymptote moves over here to the right 3. But this asymptote does not move at all. So now we're going to draw this. I know the graph is kind of messed up, but that's where the picture is. So adding and subtracting in the denominator controls what? It controls moving it left and right. If you're adding, it's going to move it left. If you're subtracting, it's going to move it right. Remember, it's always backwards to what you think because it's with the x. We're really going to call this the vertical asymptote. So your denominator controls your vertical asymptote. Vertical means it runs up and down, and so this is going to be our x equals some number asymptote. Now we have a number on the outside of the fraction, not included in the fraction at all. When you go to graph this, I'm just going to put this in the calculator and you'll see that our asymptote has moved up here. But it hasn't moved left or right, so we still have this asymptote. And then of course you still draw it in the upper right and lower left quadrants that the asymptote creates, not that the x and y axis creates. So what do you think adding and subtracting a number outside controls? If you're adding, it's going to make your graph move up. If you're subtracting, it's going to make the graph move down. Also, we're going to call this the horizontal asymptote. And when you write a horizontal asymptote, it follows under the pattern y equals whatever your number is. So now our asymptote is up here, y equals 3. All right, we have one more that we're going to throw in the calculator. Take a look at it. If we put a negative, and I'm calling this a negative in the numerator, the asymptotes will remain the same right here and right here. But what happens is it's no longer upper right and lower left, it's upper left and lower right. So a negative in the numerator is going to be reflect over x-axis. So now when we go to graph this without the calculator, in the denominator that controls left and right. So we're going to move this thing left 2, and this minus 4 on the outside controls the up and down. We're going to move it down 4. And when we say move, we mean the asymptotes. You draw the asymptotes first. So we're first of all going to draw, I'm going to draw the left one 2, and then I'm going to draw the asymptote down 4. You absolutely have to draw the asymptotes, and you do that first. Because remember, we don't really plot points. No asymptotes, your graph isn't right. And then because there's no reflection, it's just going to be upper right and lower left in the quadrants that the asymptotes have created, not the x and y quadrants. Now to kind of put this all together, take a look at number 6. Can you describe all the transformations? Let's try it. Top is a vertical stretch by 2. The denominator is left and right. In this case, it's left 4. And the stick out number is down 5. Now, we do have a little bit of a trick. In the denominator, you want to be careful. The way I see it is this could be factored. So they have a 2 in common. We're leaving us with x minus 3. That x minus 3, this is going to control left and right. Of course, that's a minus, so this is right 3. And the 2, well, the 2's not in the numerator anymore, so it's not the vertical stretch like in number 6. This is going to be a horizontal shrink or compress by 2. So we will have two things. We will have a vertical stretch and a horizontal shrink. Those are the only two things we will have. So you don't have to worry about the others. If you're struggling with this, take a look at the graph. Put it in the calculator and look at the graph, and you'll see that it really does move to the right 3. Now, in the embedded assessment, they're going to ask you about the parts. And so let's go through this. See if we can just come up with some generic way to explain each piece. The number in the top, this is your vertical stretch. I don't know if D is maybe easiest. D is your up-down. Another way we're going to call this is the horizontal asymptote. Right, so we are going to refer to it by the horizontal asymptote. Now, B. B, if you go back up and you look at number 7, I'm talking about this 2. Right? B goes like this. So this is going to be a horizontal shrink. Now, C over B. This is basically what we did with the 2 and the 3. We sort of factored it out. So if we go back up to problem number 7 and we say, okay, 2x minus 6 equals 0. 2x equals 6. We get x equals 3. So we still end up with the 3. And so if we just shorten that up and just call it c over b, or 6 over 2, you'll end up with this. This is your left or right, of course, which is now going to also be our vertical asymptote. Remember, the asymptotes go on the graph first, and then you just draw in the branches. All right, let's try if we can put all this together here. So for number 9, it says we're starting with our parent function, 1 over x. We are to name our new function mx. It's translated 1.5 units to the right. Well, I know that's in the denominator. I'll just call it 1.5. Up 3. Well, up sticks out. Not a part of the fraction, not in the numerator, not in the denominator, just out there. Stretched vertically by a factor of 2. That goes in the numerator. Compressed horizontally by a factor of 2. Well, now I've got to throw in parentheses and then put that in there. And then reflected over the x-axis. Remember, reflected over the x-axis means a negative sign in the numerator. That is the answer. If you would rather have it multiplied out, just distribute the 2 in the denominator to x minus 3, and then the plus 3 is not affected by that. So this is the simplified version. Both versions are correct, and you could leave it either way. Make sure you do the homework for tomorrow.